Hello everyone, and welcome to today's learning session, a framework for defining and monitoring forest degradation, organized by World Wildlife Fund's Forest and Climate Program. Thanks for taking the time to join us. My name is Green Burns, and I'm a Program Officer for Learning and Communications. Our presenter today is Ian Thompson, a research scientist with the Canadian Forest Service, who is joining us from Ontario. Before we begin, I'd like to share a few housekeeping tips and reminders. Today's presentation is being recorded, and you can access the recording within a few days on our YouTube channel. To find the recording, simply go to youtube.com and search for WWF Forest and Climate, or go to panda.org/forestclimate and look for the REDD learning section. There are two audio options. You can listen via your computer speakers or dial in through the number that was provided in your registration email. It is important to note that if you experience audio difficulties while listening via your computer speakers, this can be caused by having multiple software applications open, so feel free to close some of them, or you're always welcome to join via phone. If you're having any technical difficulties, please send me a message via the chat area if possible. Questions are certainly welcome. Please submit your questions for Ian through the toolbar on your screen, and we will answer as many as possible during our allotted time. For anything that we don't get to cover, you're invited to post them on our online REDD learning platform, reddcommunity.org. After the webinar, you'll receive a link to the place on the website where you can post your questions. Thanks again for joining us, and with that, we'll get started. I'll turn it over to Ian.
Okay, good morning everyone. Thank you, Breen. I'm going to talk today about forest degradation and how we designed a way to make degradation operational by developing some criteria and indicators, and then showing a way that we can actually report this. And this is taken from the next slide, please. This is taken from a paper that we published, a group of us published earlier this year in Ecology and Society. This paper is in an online journal, and so the PDF or the HTML version is available for free. The reason we did that was so that it would be available for people and they could put it on their websites and link to it. Next slide. So I want to thank my co-authors, in particular Manuel Guaraguata, who contributed a lot to this paper, along with Kimiko Okabe from the Japanese Forest Research Institute, Carlos Bahamondes from the Chilean Forest Service, Robert Nasi, also from C4 in Indonesia, and then two participants or co-authors from the UNFAO, Food and Agriculture Organization, Victoria Hamel and Cesar Sabogal. And I want to acknowledge the Secretariat of the Convention on Biological Diversity, who supported my travel to these meetings, and the Collaborative Partnership on Forests, who initiated the project, which was led by the UNFAO in Rome and who held most of the meetings. Next slide. So deforestation, of course, is very easy to see, but forest degradation tends to be much more subtle, or is often more subtle. It tends to occur slowly over time, and so as a result it may well be difficult to discern. For example, each generation has a tendency to forget what things used to be like, which tends to lower expectations and then kind of enhances the issue. But regardless, forest degradation, along with deforestation, contributes a substantial proportion of greenhouse gases, anywhere from 12 to 25%, depending on how the calculation is made. And because we don't have a very good definition, there's really no good estimate of how much degraded forest there actually is. The ITTO is estimated, probably based on just production criteria alone, that there's at least 850 million hectares of degraded forest in the world right now. As I said, we have no good accepted definition, and although there are many definitions, all of these tend to be reductionist. In other words, they were developed for specific purposes. For example, the IPCC defines forest degradation as a decline in the capacity of the forest to store carbon. Foresters tend to say that there's productivity problems. So these are the kind of perspectives that are out there with respect to forest degradation. Regardless, because of the importance of REDD now, for example, it's important that any definition should probably be linked to the climate change, because deforestation and degradation are the two Ds in the REDD acronym. So the next slide, please. So the collaborative partnership on forest defined forest degradation as the reduction in the capacity of a forest to provide goods and services. This tends to be still a very definition, and it's not particularly operational, but it came from a review that Marco Simula did on behalf of the FAO, and was published in this article, or in this paper that is available from FAO if you're interested. But there's a very large number of definitions that he considered when looking at this. And so it's important, though, that any definition be made operational. So in other words, that we can actually measure it and make a decision based on those measurements. So the next slide. So it can be caused by many things. Breen, next slide. So degradation can be caused by many things. Most of it is caused, of course, by unsustainable logging practices. Forests are degraded in many parts of the world also by invasive species and also by fuel wood gathering. And it's always surprised me that the amount of wood that's actually burned for heating and cooking is more than all of the wood that goes into paper and wood products combined. So fuel wood gathering is one way that forests can certainly be degraded. They can also be degraded by excessive wildfire. So this is beyond the normal range of wildfire. Improper shifting cultivation, for example, is another land management tool that may result in forest degradation. And of course, clearing land for agriculture clearly degrades forests. Next slide. So everyone seems to know what a degraded forest looks like, but unfortunately not everybody's ideas about this are identical. And so ultimately, people will have to decide whether a forest is degraded or not. We'll have to make a societal choice. But the important thing to remember is that a forest degradation is both a state and a process. So we can say a forest is degraded, but during the period of time that it is losing its goods and services, or its capacity to produce those goods and services, the forest is being degraded. So it's a process as well. And degradation, of course, needs to be considered at scales. So you can degrade a forest stand, but one degraded forest stand doesn't necessarily make a degraded forest landscape. And as I said, people's perspectives change. So a planted forest may be degraded from a biodiversity perspective, but for somebody who planted that forest and is producing a sustainable amount of wood, that stand is not necessarily degraded. And so a planted forest may be degraded to the stand scale, but at the landscape scale, all of the goods and services and all of the species may still be present. And so having a few planted forests in terms of plantation, fastwood plantation and so on around, may not necessarily be a bad thing, and it certainly doesn't degrade the entire landscape. But the key is to consider multiple goods and services at a landscape scale. So when we're thinking about degradation, we have to get away from the idea about degraded at site level or degraded at stand level and think more about landscape level changes. The next slide. So degradation, trying to make it operational, we developed criteria and indicators. And degradation and sustainable forest management are really sort of opposite sides of the same coin. Next slide. Thank you.
And if you can, sorry to interrupt, if you can move a bit back from the microphone, that would be great.
Okay. Is this better?
Yes, thank you.
Better like there? Okay. So as I said, degradation and sustainable forest management are kind of opposite sides of the same coin. So if you're managing in a sustainable manner, you're probably maintaining all the goods and services that you would like to see come from that forest. On the other hand, if you're not managing sustainably, you're likely, from some perspective at least, degrading the forest. And so we've chosen several criteria, all of which occur, for instance, in some of the sustainable management processes, such as Montreal process or Forest Europe and like that. And these 5 criteria include productive function, which is basically a measure of the production of goods and services that are valued that are coming from the forest. Biodiversity, which we largely consider at the kind of species level. Carbon sequestration and storage. And unusual disturbances, and I'm going to talk a little bit more about that one later because it's a bit of an odd one compared to the others. And then protective functions, which are the functions that the forest does from an ecosystem perspective by maintaining soils, maintaining water, and so on. So these criteria are not necessarily meant to be equivalent, and clearly some may be more important than others depending on the situation. And of course, only governments will probably decide whether they'll use all of them or some of them. But if you're thinking about sustainable forest management, then it is certainly our opinion that all 5 need to be considered if you're managing a forest in a sustainable way. So the basis of the criteria is that all of the criteria are basically affecting ecosystem goods and services, and hence the value of the forest ecosystem to people. So as I said earlier, degradation is equivalent to the loss of the expected goods and services that would come from that forest. And goods and services, in case you don't know, are basically forest products. So these are valued products that are used by people. They're also including some non-valued services and products, for example, clean water. And biodiversity underpins and supplies many of the goods and services, but not necessarily all. And of course, it's also possible to degrade forests with a minimal effect on forest appearance, for example, through the empty forest syndrome, which is the way people have started to describe the idea of the excessive hunting of bushmeat in certain tropical areas, for example. So the lack of these large animals results in a lack of seed dispersal or a lack of other ecosystem functions that they provide within the system. Carbon is clearly linked to biodiversity and production, but is of individual interest, particularly with respect to climate change, of course. And certain environmental processes, if they become excessive or abnormal, also degrade forests. And then we need criteria to suggest degradation as either a state or a process. So these are all some of the considerations that we looked at in terms of developing the criteria. So we also need a baseline or a reference condition against which to measure our indicators to suggest whether or not the forest is being degraded or not. And so in this graph, the upper line shows kind of a natural range of variation. And so in any given year, because weather changes and so on, there are variations in the production of goods and services from a forest. And so that upper line is meant to illustrate that within bounds, the forest provides kind of a stable level of goods and services. However, if as a result of whatever factor, such as bad forest management, one of the goods and services that you measure as an indicator starts to decline and falls below the expectation for a period of time, then we would start to say that the forest is degraded. And so it's particularly important then to establish a baseline to decide against which to measure your indicators and decide what levels will be acceptable in terms of a sustainable production. And so depending on the circumstance, this baseline might be established from using primary forest as an example, or it might be done using a sustainably managed forest where there's clear objectives are being set for the forest. It also has to be done at different scales, because forests at different ages, of course, provide different goods and services. And just because a forest is in a young successional stage does not mean that it's degraded. So our suggestion is to consider degradation over several thousand hectares. So our first suggested indicator on the next slide is with respect to forest production. And so these are the actual production of measurable goods and services that come from forest. Forest production, for example, is a main goal of forest management. And unless there is some sort of a long-term decline, then no degradation is occurring. So sustainable forest management suggests that on a forest landscape you can produce a certain wood volume and other goods and services sustainably over time and still maintain all the recognizable features and the goods and services that you would expect to come from that forest. And foresters measure a forest production in terms of, for example, a mean annual increment or the growing stock. So there are many measures, many ways of measuring the growing stock within the forest. And much of this can actually be censused remotely, either using LiDAR, for example, which is probably the best, but also radar sat. And this is already reported in the FAO's publication, which they call the Forest Resources Assessment, which is done every 5 years. And companies, or countries at least, make reports directly to the FAO on their forest production based on mean annual increment. Non-timber forest products is another one of the indicators that we would suggest. Very few NTFPs can actually probably be measured remotely, so most of these would require local data. There are, however, some proxies, for example, such as rapid assessment protocols for rural areas, or local knowledge about declines or losses can be assessed, and sometimes distance traveled to obtain a particular non-timber forest product might give you a good indicator that things are actually being degraded. For example, the distance traveled near cities to obtain fuel wood, for example. So that's our production indicator. The next indicator is with respect to biodiversity, and here we're talking mostly about biodiversity at the species or ecosystem level. These are the levels of biodiversity that we can measure. And our first indicator is ecosystem state, which basically refers to kind of the recognizable state of the dominant vegetation. So basically the tree species mixture that you expect for that forest. And so a change in state from, say, a mixed wood forest to a deciduous forest, or from a dry forest to a tropical savanna, all represent a change in state and represent a form of degradation. So when you change the state of the ecosystem, you generally change also the goods and services that you were going to expect from that system. And so you get far less, or you get very different goods and services from a savanna as opposed to what was there previously in terms of a tropical dry forest. Ecosystem state can almost always be measured by remote sensing as well. Forest fragmentation is our second indicator, and it's a measure of the amount of forest loss within a normally continuous forest landscape, which can also be measured by remote sensing, and again is already reported to the FAO for their forest resources assessment. And fragmentation tends to be a very slow process of forest loss as continuous forest becomes fragmented, and the individual forest fragments suffer a number of processes that lead to species depletions and degrades the goods and services that can flow from the forest. Our third indicator is species. Now, species is obviously going to differ depending on your individual situation. Obviously, species change depending on what forest type you're in, what country you're in, what continent you're on, and so on. And so individual species, although they can't be measured remotely, are used by most forest agencies and environment agencies around the world now as indicators. So these are things like flagship species or featured species or focal species that are used to suggest sustainable forest management. We also suggest that attention be paid to, for example, key functional species. So these are pollinators and so on, because these are the ones that have very strong functional relationship to the production of goods and services on that landscape. In the case of tropical forests, actually some tree species may have exceptional value, and it might be useful to monitor their populations directly as an indicator of forest change. Excuse me. There's lots of criticisms about monitoring animals. These are mostly related to high uncertainty of the estimates, but obviously these kinds of criticisms don't apply to tree populations. So on the next slide, we're talking about unusual disturbances, and this was a kind of a difficult criterion and one that we talked a lot about. People, wanted to talk about forest health, and some people didn't like forest health, and then we talked about abnormal disturbances, and we finally settled on unusual disturbances. But the idea is to try and convey the idea that natural disturbances that become excessive. So, for example, wildfire is one of the indicators that we would use, can certainly damage an ecosystem if they happen more regularly than they normally occur within that system. Wildfire is another indicator that's also already reported to the Forest Resources Assessment of the FAO in terms of area burned. The second indicator is that we thought was alien invasive species, and these are species that cause damage within a system. These can often, well sometimes anyway, be measured by remote sensing. Sometimes in terms of area that has been damaged. For example, in eastern North America, part of the world where I live, it's fairly easy to measure the damage that's been caused by the emerald ash borer because of the death of ash trees across much of the eastern part of the continent now. In other places, it may be necessary to measure invasive alien species on the ground. And so we find that these two indicators together probably provide a pretty good indication of unusual disturbances across a landscape. Our fourth criterion and associated indicators we talk about protective function. And so these are the ability of the forest to protect soil and water and provide those services. And our two indicators are eroded soils and water flow or quantity. And soil erosion can usually be measured remotely because it's quite visible on aerial photographs and even on satellites because the vegetation cover changes dramatically, and so it's fairly easy to recognize this on a remote sensing platform. And water data are also usually available historically, but in the case of water flow, we can't really be measuring it remotely, but certainly water flow rates are known to be related, for example, to forest cover. Not necessarily to biodiversity, but certainly to forest cover. And there's a very nice study coming from work by Antonio Lara in Chile, talking about less regular and more pulsed flows of water flowing from plantation forests, rapid growth plantation forests, for example, compared to the natural notophagous forests in that country. So it's a way of showing degradation from that particular perspective. And our final criteria is measures of the amount of carbon that are stored in various pools within the forest, and the IPCC recognizes these 5 pools. This is above ground biomass, below ground biomass, dead wood, carbon stored in the litter, and organic carbon stored in the soils. And the IPCC also provides guidance on how to calculate these. These are also a value that's reported already to the Forest Resources Assessment, and so the data is often available at a country level. And so carbon storage could be part of our productivity criterion, but we separate it for 2 main reasons. First, because it is singularly important under REDD, and also to the UNFFF, or the climate change negotiations. And secondly, because production would only assess the above ground biomass opposed to the total carbon within the system. And a paper by Bob Chasden clearly related the capacity of a forest to store carbon to the state of degradation, and he showed a very nice graph in that paper showing the decline in the amount of carbon relative to the amount of biodiversity that was within the system. The second density, or the second indicator that we are suggesting, is high density wood species, and this is very strongly related to the biodiversity indicator. But the loss of high wood species in a system usually occurs because they're selectively removed from forests because of their exceptional value in terms of producing wood products. And they tend to lead to reduced future value within the forest, although the canopy may not change. It's another one of these examples where there's kind of a subtle change across the landscape. And while the canopy may not change, and you may not see the change through remote sensing, in fact, the forest species composition has changed. And so you get this form of reduction in terms of the value that the forest might produce to future generations. And loss of these very high density species also reduces the total amount of above ground biomass that is stored within that forest over time, particularly when they're replaced by much less dense wood species. So for the next slide, we have a suggested minimum set of indicators. So the important point that we're trying to make here is that a forest can be degraded from many different perspectives. But if you're trying to maintain a sustainable production of goods and services and managing your forest using sustainable forest management, then you need to have indicators for each one of these criteria that we've suggested. And since degradation is a continuation of change over time from lightly to severely degraded down to deforested ultimately, the indicators will represent a trend, and if the trend is consistently down, then degradation is occurring. And so the question arises, well, how often should we measure these indicators? And the answer is it depends very much on the indicator itself. So if there's high variability within the population, you may want to measure it more frequently than if there's low variability within the indicator or the population that you're measuring. And you need to establish a trend over time because, as I said, degradation is in fact a continuum. And so the way we report this is by using this kind of a spider diagram. And so this gives the forest manager, or who's ever deciding whether the forest is degraded or not, a way of immediately suggesting what kind of degradation the forest is undergoing and whether or not some forms of degradation are more prevalent than others. And so the outside ring represents the full suite of goods and services, or level of biodiversity, or level of carbon, or the the natural level of unusual disturbances that occur within the forest, and then the measured values shown here in this red line would show that the forest is slightly degraded in terms of the protective functions, moderately degraded because unusual disturbances are occurring more often, and so on. And so this is we think is a very nice way of reporting a degraded forest from a sustainability perspective. And so then in conclusion, what I want to bring to your attention is that degradation is not only a state, so the forest is degraded, but it's also a process, and it tends to be a very slow process over time. And that process and the recognition of that process tends to be affected by individuals and institutional memories. So we need to have a baseline that goes back a reasonable ways. Indicators will all have to be selected for local forests, but the use of the available sustainable forest management or global indicators is certainly preferable. And so using many of the indicators that are, for example, already reported to the FAO for their forest resources assessment makes good sense. And the data must be reported as an area degraded by degradation type. So what kind of type is occurring and how much area is being degraded. And you need a baseline that reflects the range of natural variation. And so you need to understand what is the sort of natural range of variation that occurs in that system by establishing a baseline again over time. And our key message is that there are multiple perspectives with respect to forest degradation. And so your idea of a degraded forest may not be the same as my idea of a degraded forest. But if we use these criteria and indicators, then we can at least all be talking the same language. And all of our criteria relate to ecosystem goods and services, in other words, values that humans derive from the forest. And if we're thinking about managing the forest sustainably, then in terms of degradation, we would have to use all of our criteria with indicators for each one. And so that's basically what the paper says, and I guess we're open for questions through Breen.
Well, thank you so much for that great presentation, and please feel free to submit questions now for Ian. And to get us started, Ian, I have a first question for you. And the first question is, how do these criteria relate to those used by some of the sustainable management protocols, such as Forest Europe?
Well, okay, so what we tried to do was use several of the criteria that are already being used in some of the sustainable management protocols. There's 8 of these sustainable management protocols around the world, and not all of the criteria and indicators that are used by each of them are the same, but many of them in fact are, and many of them are the ones that we've actually selected as some of the criteria we would suggest as a way of looking at forest degradation. And so if you go to, for example, the Montreal process or to Forest Europe, you'll find most of these indicators there.
Great, thank you. The next question we have is, are these the only indicators that you would suggest for the 5 criteria?
Well, actually, we suggested more indicators in the paper. So if you went and looked at the paper, we had suggested some other indicators. And what I've tried to present here are the ones that you could actually census using remote sensing as much as possible. The reason for wanting to use remote sensing is because you can actually buy the data from a company that owns a satellite, for example, or somebody can invest in developing a degradation framework for you by providing the data or by buying the data from. And by buying the data, I'm suggesting getting a hold of the satellite images. Some of the images are actually free, and so you can download many images for Landsat, for example, now for free. The issue, of course, is having the technical expertise to interpret those in light of A, a baseline, and B, what the image actually means. And so what we tried to do then, anyway, was at least provide indicators that would give us a good first approximation of whether a forest is being degraded or not, and that could be done by a technical staff somewhere. It doesn't necessarily have to be within the country where we're questioning whether or not the forests are being degraded. But they might be done, for example, through a project at FAO or through World Bank or something like that.
Great, thank you. So our next question is, you mentioned that some environmental processes, when abnormal, can degrade forests. Can you please give an example of this?
Yeah, so for example, in many parts of the world, in particular the boreal forest, what we're starting to see is more wildfire now than we used to see. And this is a combination of two factors. There's been some unusual outbreaks of insects, for example, which have resulted in larger wildfires than we might normally expect, both in Canada and in Russia. And the trend for wildfire in boreal forests is just generally up, largely because of the global warming that has occurred. And as a result of that, in many years, boreal forests now have started to become a source of carbon, whereas not very long ago they were actually a sink. And so from that particular perspective then, in terms of the total carbon that is being accumulated in boreal forests, then these forests have started to go through a period of degradation from that perspective. They are not being degraded, however, at this point from other perspectives. So, for example, we're not losing biodiversity. The forests are still being managed sustainably, and so on. But from the carbon perspective, they've started to be degraded. So that's one example, and there are, of course, other examples around the world, particularly related to insects, windstorms, ice storms, and fires.
Great, thank you. So the next question, well, let's see what you know about this, because the question is about related to WWF. But our attendee asks, I'm aware that WWF has been using UAVs for poaching applications, and I'm wondering if they are using them to collect data to monitor some of the indicators you mentioned at relevant scales. So I know you're not with WWF, but do you by any chance know if that's happening?
Well, first of all, I'd have to ask what a UAV is.
It's an let's see.
Perhaps the questioner could clarify.
Yes, we'll come back to that one. I think it's an unattended, like a drone, essentially. So we'll come.
Oh, I see. Yeah. Yeah. No, I'm not aware of that at all.
Okay. We'll come back to that one.
I do know one thing. I do know about if you're talking about assessing forests by the use of drones. I know there's a lot of work going on right now with respect to that, and the use of LiDAR from these drones. LiDAR gives you a wonderful, it's basically a form of radar that gives you a wonderful three-dimensional picture of the forest and allows you to assess a large number of structural features within the forest, as well as gives you an excellent measure of biomass, above-ground biomass in the forest.
Well, thank you. That actually leads into the next question that says, if I understood you well, you mentioned that LiDAR is the best option for estimating growing stock. Why? Do you take into account cost, precision, requirements, operativeness, etc.?
Okay, if I said best, I probably didn't mean best. I probably meant that it is the best remote sensing way of measuring growing stock. Certainly the best way is on the ground. But when we're trying to do this over a large area and using remote techniques, then LiDAR is far superior to, for example, using something like NDVI or FPAR from either Landsat TM or MODIS, for example. Simply because it gives you an excellent picture of the exact size of individual trees and provides a good measure of forest structure for above-ground biomass. It doesn't give you the accuracy that a ground survey would give you, though. There's no question about that. But at the same time, you can cover a much larger area, but it is expensive.
Well, and again, that ties into our next question here. And this person asks, do you think that participatory land use mapping could work instead of satellite image data for defining and quantifying forest degradation in an area or region?
Yes, absolutely. And on-the-ground data is better than anything that we can do remotely right now for almost all of these indicators. And so in terms of participatory mapping, if I understand that correctly, it would involve a lot of local knowledge and developing maps in terms of areas that are degraded versus areas that are not degraded. But we have to keep in mind that we would have to be considering many of the, or all of the 5 criteria that we've suggested. So this will still involve some use of expertise beyond what you might get at a local level.
Great, thank you. So the next question is, do you think that most developed countries would be capable of using this method to determine degradation in their forests?
I think developed countries would, and I think some developing countries would be capable. The difficulty, of course, is that most degradation, forest degradation, is occurring in undeveloped countries or developing countries. But I think that, you know, for example, most developing countries also don't have a very good forest inventory. But organizations like World Bank and FAO in particular are working with these countries to develop a good forest inventory. For example, I know the FAO has funded the development of forest inventories in places like Kenya, Nicaragua, and Brazil. And so if the effort is made by these organizations to start to quantify forest degradation in the same way that they're providing aid to develop a forest resource inventory, then I think it could probably also be done. And this is why we're trying to promote the idea of using some of the remote sensing techniques to at least give us a first approximation of the amount of degraded forest that is there. The amount of degraded forest also, of course, is, you know, we're working towards using some kind of a working definition so that improvement projects can be funded under REDD.
Great. So the next question, let's see. Next question says, I like the emphasis you make on capitalizing on existing and very mature SFM criteria and indicator process, some more than 20 years old, as well as the use of known proxies that can be derived from RS data that come from many years of landscape ecology research to draw a first-level assessment of biodiversity status. However, would you agree that these should be used on a course to find strategic filtering approach in order to target areas in which additional scrutiny would be required? Let's see if I can.
Yes, absolutely. Yeah, I understand the question.
Okay, you
do.
So
the question, yeah, sure. So remote sensing, you know, for some things is a very accurate tool. It's very good, for example, at providing information on total forest area, forest cover, for example. It's very good at providing information on fragmentation, for example. But in terms of providing actual strong data, for example, on biodiversity or on the amount of carbon that's in a forest or the amount of soil erosion that's occurring, it doesn't do a particularly good job. It does, as I said, it approximates it. And so if you want particularly good data, there's nothing better than supplementing remotely sensed data with ground studies as well. And so it's often very useful, for example, to develop some NDVI indices which would suggest that the forest is being degraded from a productivity perspective by saying, okay, we're going to suggest that the forest is being degraded if we get an NDVI that is, say, 20% less than what we expect or what should be produced by that forest. What would give you much better data is to take that NDVI measurement and then go into the forest and use a number of plots to look at exactly what is happening to the forest in terms of how the degradation is actually occurring, not only from the productivity perspective, but also from other perspectives. And so, yes, I would firmly agree that what we're suggesting here will give us kind of a first approximation level of degradation, but this needs to be supplemented in many cases, and in particular with respect to species, by ground data.
Our next question is, reference level is supposed to be expressed in TCO2 equivalent. How do you convert these indicators into CO2 equivalents?
What kind of CO2 equivalents? Sorry, I missed that.
Let's see. Let me see if this person wants to. I will unmute Eugene.
No, I just didn't hear what you said. Tons of CO2, I think, is what it is?
Yes.
Is that what it was? Tons of CO2?
Yes.
Yeah, okay. And so could you just read the question again for me?
Reference level is supposed to be expressed.
So it's tons of CO2 equivalent?
Yes. How do you convert these indicators into tons of CO2 equivalent?
Tons of CO2.
Let's see if...
So the way IPCC calculates total carbon in the system is there's a protocol that's available. So this is another example of one of these things you can do remotely. But there are protocols available if you go to the IPCC website, which allow you to calculate carbon in each one of the pools. That can be converted to tons of CO2. I mean, I don't have any better answer than that.
Okay, thanks. And people can always follow up on redcommunity.org if they need additional information.
Yeah, there's a lot of information available about you know, how carbon in systems is calculated. One of the things that has bothered me about the amount of carbon in systems that tends to be calculated is they don't tend to have an error term. And this again is an example of where we need a lot more groundwork to provide error terms.
So our next question is, could you refer to the scale to which the proposed indicator should be measured?
Yeah, so what we've tried to do is provide indicators that you could use at a stand level if that's what you wanted to do. But we feel it's more appropriate to measure these things at a larger landscape level, particularly things like ecosystem state and so on. So our suggestion in the paper was that we probably ought to be looking at these indicators in terms of several thousand hectares, and I think in the paper we actually suggested as much as 5,000 hectares might be a reasonable scale at which to look at these things. And this is partly because forests are constantly changing, and in some forest types, those particular that are disturbance-driven, the forest landscape will occur in multiple age classes and multiple forest types at any point in time. And so it's important to look at the goods and services that are being produced over a sufficiently large area so that you can kind of get an average over space as well as over time. So, you know, it's going to vary depending on where you are in the globe. But the indicators will work at the stand level, but we think they would work far better if you considered at least several thousand hectares as the kind of scale that you might look at.
Our next question is, use of remote sensing to quantify a carbon stock is only as good as the classification of the pixels, spectral value, and knowledge of the biomass content on the ground. How can this be applied across a large area where ground data is sparse and not necessarily geolocated, and availability of satellite imagery is sparse because of cloud cover and no images?
Yeah, well, that's a very good question. I think probably the best you can do in situations like that, and there are averages calculated for most of the major forest types. And so probably in those situations, the best you're going to be able to do is provide an average value that is going to absolutely have to be supplemented with ground cover data. So I don't think there's any way of getting around that in those particular cases. It's relatively rare on the globe, though. I think that you know, most of these things, we're talking about cloud forests and so on. But most forest types can certainly be sensed using remote sensors. The other thing I would bring out too is that some of the new radar technology that is starting to be applied through satellites will see through clouds, and so I think this holds promise for those situations where getting good satellite imagery may be difficult.
Great, thank you. The next question asks, for the purpose of REDD Plus under the UNFCCC, reductions of forest degradation has to go through the MRV in order to be counted for and eventually paid for, which is, however, not decided yet by the UNFCCC. Which indicators you listed do you think would be chosen and applied globally in the future?
Okay, so that is a correct statement, but let's keep in mind that there's many bilateral arrangements that are already currently occurring. Some countries are actually working directly with other countries and developing REDD, and I can think of the Japanese, for example, and the Norwegians as another example, who are using MRV as a mechanism to fund these projects. I would hope, and it was the purpose of our paper, that all of these indicators would be picked up under UNFCCC and used as a way of developing a means for assessing forest degradation and applying the criteria with respect to funded projects.
Great, thank you. So while questions are still coming in, I'm going to go ahead and flip through to this next slide and just let people know about some additional WWF REDD resources here. And again, please feel free to continue to submit your questions. The first is a guide to building REDD strategies, which is a toolkit for REDD practitioners around the globe. We also have an archive of this learning session and our other learning sessions available online. As I've mentioned a few times, redcommunity.org is a free and open online platform for REDD practitioners, so please visit, join, and post your additional questions for Ian there, and we'll make sure he gets back in touch to answer those for you. And finally, REDD Resource Digest and Canopy are two free online resources that we at the WWF Forest and Climate Program send out. And you can always find more information at panda.org/forestclimate. So let's get back to our questions. So let's see, the next one says, the means exposed here are not only useful for degradation assessment, but also of biodiversity safeguards. So I suppose that's not necessarily a question, but a comment. So thank you for that. So do we have any more questions? Or Ian, as we start to wrap up here, do you have any more comments, or do you have any questions that you typically receive from people when you give this presentation that hasn't come up yet?
No, actually, the questions that have been asked have all been, very good questions. And so I very much appreciate the participation of the audience on this. This came about as a result of a lot of discussions among people at some original meetings at FAO, but then as a result of a large discussion through the group of co-authors that we had. And so it took actually a long time to come up with this, simply because, as I said, most people have a particular perspective about what a degraded forest is. So if you're a forester, you're thinking about the wood that should be produced. Whereas if you're somebody who's more interested in nature or biodiversity, or interested in maybe species that have started to disappear and so on. And so I think, the important message that I want people to take away from this is that, there are many perspectives about what a degraded forest is, but we need to be able to consider it from multiple perspectives.
Great, thank you. And we do have a few late-breaking questions here. So the next question that's just come in is it correct to understand you're suggesting the coarser landscape scale as a focus level, and that meanwhile hierarchical multi-scalar analysis would be useful?
Yes, very much so. So we think the landscape scale is the most appropriate scale at which to measure degradation. But obviously the landscape is the sum of the parts, right? So it's the sum of the stands that are being degraded or not being degraded that result in answering the question at the landscape scale. But you can apply these criteria certainly at a stand level over time and again over space as well. So yes, we're thinking that this gives us a coarse approach at a coarse scale, but the criteria should also be implemented, if you like, also at relatively small scales.
Great, thank you. So, and again, as we wrap up here, I just want to remind you that you can stay connected with us on Twitter, on the web, and you can always email us for more information at forestclimate@panda.org. And with that, I think we will bring it to a close. And if you have any additional questions, please feel free to email them, or if you posted them and we didn't get a chance to answer them, I will make sure that they are up on redcommunity.org. Well, let's see, there's one more that has just come in. What is your opinion about VFC as a proxy of degradation? This is a new variable included in FAO FRA 2015.
What's the variable, DFB?
About VFC.
VFC.
And
I can't remember what that variable is. I work with FAO and I can't remember it.
Let's see. I will see if Carmen would like to clarify. I will unmute Carmen once I find her on our list. So, Carmen, you're unmuted.
Oh, sorry. This is a product derived by MODIS imageries, and it's an algorithm in try to get the percent of tree cover. And right now, this is included in the new proxies of degradation in the report of the FAO for FRA.
Right, right. Okay, so it's virtual forest cover. I understand. So this arose from a discussion that I had with the FAO people when we were there talking about degradation and a way of getting at it. I think it's okay as a first approximation, but again, it has to be measured against a baseline. So you need to know the baseline values. But what they're basically saying is that if from our MODIS image, the measurement of NDVI had declines by a certain percent, and I think they've chosen 20%, then we suspect that that forest is degraded. So 20% over what we might expect for the forest. And I think it's fine as a first approximation. But as many people have pointed out, there's questions about whether that is still within the range of natural variability for some forest types, and there's a question about whether or not MODIS gives you an accurate enough picture to suggest that 20% does indicate forest degradation, and so it needs some groundwork. But we have to keep in mind that we need to start somewhere, and also that there's many things in the FRA that people don't necessarily agree with the definition. For example, many of us don't agree with the definition of forest itself that the FAO is using, which is 10% cover, and I can't remember exactly what it is, but many people feel that definition could be altered. But it doesn't matter because they've explained what they're doing. So this is how we define a forest, and this is how we measure it. And in this case, this is how we're defining degradation as a first approximation, and this is how we're measuring it. So long as you understand how the variable is being achieved, how it's being monitored, and what the definition is, you can make up your own mind about whether it actually means something. In this case, I actually think it's quite a good proxy, quite a good variable, but one that does require a certain level of ground truthing ultimately to verify that in fact the numbers that they do use for NDVI and degradation are in fact accurate.
Great, thank you. So our next question is, from what I've heard, LiDAR cannot be used for wall-to-wall mapping in large areas. It would be too expensive to use it in this way. Do you think a feasible approach would be using LiDAR or very high-resolution optical radar data over some selected areas plus ground data in order to build models? Would be later applied over the entire area of interest?
Absolutely, and that's the way that LiDAR is being used now, and it's certainly the way in which that it'll be used in the future. What I do believe, though, is that the cost of LiDAR is going to come down substantially. And this gets back to the question about the use of drones, for example. Right now, of course, you're paying people to operate airplanes and tabulate the data and so on. But as these systems become more automated, the cost of using LiDAR is going to go down dramatically. Nevertheless, it does actually require an aircraft to fly over a particular piece of land and take the radar photographs. Now, that said, the other thing that I did bring up earlier, and I'll say again, is that there are satellites now that are having radar attached to the platforms. And so if these things hold the promise that the remote sensors say that they do, LiDAR itself may ultimately become even obsolete. But right now, that idea that's proposed, so using LiDAR to develop models for particular forest types based on a sampling design, is certainly the best way to achieve this result.
Thank you. And another question for the audience was whether or not this PowerPoint would be available. And yes, it will be available after this session, again, on REDD Community. You'll receive the link in the follow-up email from GoToWebinar, and you'll be able to find the PowerPoint there.
I would point out, too, that the paper is online, so it's available, and the reference to it is in the presentation. But it's on the website of the journal called Ecology and Conservation.
Great, thank you. And I think, let's see, we may have one or two more questions. Let's see. So I think with that, we will bring this webinar to a close. And thank you to Ian for being with us here today and for giving us such a great and useful presentation. And thanks to our attendees for asking such good questions. And again, you can stay connected with us here, and in the follow-up email that you'll receive, you'll find a link to reddcommunity.org, the specific place on that website where you can post additional questions. I will post this PowerPoint. I'll also post the link to the paper, and we'll make sure you get all the answers to the questions you may have. So thanks again, everyone, and with that, I will bring us to a close, and until next time. Thanks, Ian. Bye, everyone.
Okay, thanks, Breen. Bye now.
Bye.